So welcome for the second session of today. I already see a couple of names on the poster, so make sure during the next break to also write your name on the poster as well, so you can prove that you were at BSides Groningen. For the next talk, I'm going to introduce Thomas and Erieke from TNO, and they're going to show us how amazing WuppieFuzz is.
Thanks for the introduction. Yeah, so today we will take you along with how to go for automated REST API vulnerability detection with WuppieFuzz in particular. We dive a bit deeper into the marvelous world of fuzzing, and Erieke will also zoom in to the specific application of API fuzzing. Maybe to start with, so who are we? We were already nicely introduced. We work for TNO. I work as a lead scientist on topics like cybersecurity by design, software security, and vulnerability research. So if you have any questions on those, feel free to ask. I also have a background in privacy enhancing technologies, so if you want to ask some crypto stuff, you can also ask me during the many breaks. And this is Erieke.
I'm also a scientist at TNO. I guess I work on mostly the same subjects as Thomas. I also sometimes do some monitoring and detection, which is quite interesting. But mostly vulnerability research and how to help others not be that vulnerable, which is also what today's talk is about.
Yeah, thanks. So let's start. Let's see if the clicker is working. Yeah, so I just want to take you along with fuzzing. I'm assuming that not everyone in the audience has an idea what the term fuzzing means, or fuzz testing. So it's a software testing technique. And the key principle is actually more like this image. So I got the credits for the image actually in the bottom. But it's more like if you leave your device somewhere in an uncontrolled environment, you might have a kid that walks to your device, is trying all kind of random things, button smashing, and all of a sudden they either break your device or they get in, and you have no clue how that happened. I think that's a nice way to describe fuzzing. So if you formalize it a bit more, it's, you try all kind of unexpected and seemingly random input data, shoot it at your application, and you try to trigger unexpected and breaking behavior. I have to click a bit earlier, I guess. Yeah. All right. So what are the key aspects of fuzzing? Well, it's driven by a high volume. You want to try a lot of different things, because if you do random stuff, well, many of the things don't really have an impact or an effect. The nice thing of fuzzing is that you really decrease your testing bias. So if you're a software engineer or a software developer, you are very good at testing the happy flow. If a program is supposed to do something, you know how to test it. You might be able to get to some unexpected behavior as well and try to test that also. But it's very hard to test the things that you don't really know that they are there. So testing the unexpected. So you decrease your testing bias, and you can also automate this fully, so implement it in your CI/CD pipelines. I hope conceptually this is quite simple, but in practice it's actually a bit more complex. We'll dive into that in the rest of the presentation. But to make it a bit more visual, we also brought an example. So if you're fuzzing, and this is, for instance, starting input that you want to mutate and change, we actually did this with this Super Mario image, and we fed it to an image parsing library just to demonstrate what a fuzzer is doing. So if it starts fuzzing, it will try all kind of random mutations, and this nice GIF is actually showing the various mutations it's making. Of course, only the images that you can actually view. Many of the inputs are also so that invalid that you don't actually see it. Before diving even deeper into what we can do with fuzzing, I believe there are quite some misconceptions, and I want to discuss those with you. So first off, some people think that fuzzing is a form of stress testing. I don't agree with this. Of course, you are stress testing your application, but that's not the goal of fuzzing. So your goal is not to see how it behaves with a lot of data and a lot of, for instance, requests when you're fuzzing a REST API, but the goal is to find unexpected behavior. It's also not a technique that you're using to attack a system. In particular, you're not attacking live systems. If you would do that, there are many mitigations in place to prevent you from continuing. So if you want to attack a system, you better just run it locally, find a vulnerability, and then run an exploit in a single run. Some people might argue that it's only or most valuable when you're doing pen tests, but we also demonstrate that it's actually very valuable in other stages of your development. And it's also not only for security testing, although you might argue that depending on your definition of security, it is only for security testing, but it's also a great technique to enhance the reliability and robustness of your application. So that's the key thing I want to mention here. So when can you apply fuzzing? Well, you can do it during development. You can use it to improve your unit testing or integration testing and implement in your CI/CD environment. You can, well, of course, do it during penetration testing or testing open source software solutions that you're actually using. And you can, of course, do it on legacy software as well, or regression testing. So there are many places where you can apply fuzzing, and all different instances have a slightly different way to set it up. So why would you want to go fuzzing? Well, as I already mentioned, well, if you detect flaws, your software quality increases, and thereby also the reliability and the security of your software. So that's, I think, a very important aspect. And the nice thing of fuzzing, as opposed to more static testing techniques, is that the things you find are true positives, and you can actually reproduce them. You have payloads that you can just fire it at your application and just debug from there. Another interesting aspect, so once you manage to set up your fuzzing campaigns, it's actually relatively cheap to keep doing it. It requires minimal effort to change it when your software changes a bit. It's fully automated, and they don't really have a 9-to-5 mentality, so they just run 24/7. So that's also great. Although I can imagine many of you in the crowd also work 24/7 for fun. So what does a fuzzing procedure look like? So the first thing that's very important, often forgotten, is actually realizing what the attack surface of your application is, and how can you actually hook your fuzzer to your application. So how can you feed input data to the application in order to actually find interesting, unexpected behavior. So that's a very important aspect. Once you manage to get that going, the first step is to start generating these random inputs. Often you start with an interesting, well, working input, and you try to mutate that. This input is fed to the application and executed. And well, once you execute it, you observe the behavior. You might also observe other interesting aspects. And all these metrics that you can observe can be in turn used as feedback to improve your input generation, change your strategies, do all kind of interesting stuff. Well, once you find interesting bugs or issues with your application, you can do some crash triaging, and then there are many things you can do after that, which include, of course, building an exploit or patching the issue at hand, depending on your role. Then there are various settings. With a setting, I mean what you can access of your application. So there are many definitions of black box, gray box, and white box. And they don't really align. So we decided to at least present today one of our interpretations of what this is. So black box is really you cannot see anything. It's just the input-output is what you can see. White box would be you have the entire code base available. You can instrument the code. You can add code. You can modify it. And gray box is somewhere in between. If you look at compiled languages, you might be able to modify the binary, but you don't have the source. And the nice thing is, if you go from right to left, of course, if your fuzzer is only working on black box, you need way less knowledge of your application. But if you go the other way around, there's more information available, which can make your fuzzer way more intelligent. But this also comes with a lot of trade-offs. So there are many things to take into consideration when you're setting up fuzzing, and also specifically for your application that you're fuzzing. I listed a couple here, for instance, the performance. So performance is very important. The more you can try, the more likely you will find something. But if you do it intelligently, you might not need to try as much. Or if you can use a lot of structure or pre-knowledge about the input that you're feeding. For instance, if you're fuzzing a PDF parser, and you know that it's parsing PDFs, well, maybe you can start with a PDF or use the structure of a general PDF to create interesting new starting points. And also the amount of feedback that you can use to do intelligence thing can be tuned. So there are many combinations of these. So for instance, having a very or more or less intelligent setup, which is a bit less performant, but also uses a lot of feedback. I will not name specific fuzzes today for that, but I think people deeper in the domain can imagine what it is. Or have a very performant one, doing a lot of random stuff, maybe using some structure of the input data, but other than that, will be more like a monkey smashing buttons. And similarly, you can use a lot of intelligence, use all the feedback you can find, which results eventually in having a very bad performance. But then again, this can still be very beneficial, and there are some interesting fuzzers that actually use this approach to find deeper bugs. And with that, I want to give the stage to Erieke.
Thank you. Clicker, nice. So I will try to introduce to you the fuzzer that actually we wrote at TNO. So this is a REST API coverage-guided fuzzer. And I want to introduce slightly the many terms I just threw at your heads, even though you probably understand most of them. Because there are many fuzzers. Fuzzing is not a new technique, like we are presenting it here just in case you don't know it, but it's existed for tens of years. So what is fuzzing about? Well, actually, there are many fuzzing projects, including one currently operated by Google, that just fuzz open source software all the time. So fuzzing is not like some alien concept. You can do it at home or at work. But fuzzing mostly has been focusing on like binary applications, such as the programs you run in your terminal that just accept one input, give one output, and then it's very easy to just attach the fuzzer to the standard input and start feeding nonsense. And many applications that you use every day consists of multiple parts, not all of them like the applications you would use in a terminal. Instead, they have like components that interact with each other, and for instance, your laptop and desktop applications might connect to a backend operated by a service provider that connects again to a database. So yeah, you have multiple components, and all of these components can talk to each other, and therefore have input and output interfaces. And we set out to build a fuzzer that can test those interfaces as well, because as you know, when your mobile phone connects to a backend, you, as perhaps a security researcher, can also do this in other ways and feed inputs to this backend that it might not expect. So testing APIs, REST APIs in our case, is, according to us, an important avenue of research, and also should be an important avenue of practical testing. So yeah, how do these things communicate? Well, they use, for instance, APIs, for instance, REST APIs. For instance, one such as this one. I used an example that you can find if you look up documentation on the Open API specifications, which are often used for REST APIs. Then you get this example, which for our purposes is very nice. Because, well, you can see all the ways you can communicate with this application. You can send it HTTP requests that conform to certain rules, and then you get an answer or a side effect happens, and, well, in this case, you can update a database of cats and dogs. Then somewhere, if you actually build this app, you will have some code in the back end that does all these things. So if you send a post request to the pet endpoint with some data, it makes a new pet for you. And then, in the end, it also connects to, hopefully, a database of some kind. Of course, you can keep your pets in memory, but usually you want to reset your server at some point or run multiple ones of them. And then, well, you need a database of some kind. So, when we start... well, it works. When we start fuzzing, especially when we start fuzzing a REST API, the glitchy Mario goes into each of these endpoints. So you try to fuzz, for instance, the parameters. Because, of course, you can also just open the HTTP port and start sending garbage there, which might be interesting, but you might also just be fuzzing the HTTP parsing component, which is often not the part that you wrote yourself and that you want to actually test. So we try to make valid HTTP requests with invalid inputs for the parameters, for instance, or the cookies, or the headers, or whatever. And then hopefully these end up in your logic and start doing weird things to your database, maybe. So yeah, another thing that kind of you want to do when you're testing is you want to know how good it's going, right? Maybe at some point you crash your application, then you know you found something. But if you don't, does it work? So yeah, what we try to do also is to give you some insight in either that's where the bug is, or maybe even better, we tested all this code and we didn't find a bug. So this is like code coverage is kind of nice to have. And since our fuzzer is built on libafl, which is a coverage-guided fuzzing library, we can use code coverage if we can instrument your application. This ties into the white box, black box thing that Thomas talked about. And finally, there's another challenge. If you use a database, well, you might have to deal with the state of your application since it affects what bugs you find. If you feed glitchy Mario into your database, perhaps you don't see the effect immediately, but then if you try to do other very legal and cool stuff with your application, it might suddenly crash. And then you try to reproduce, and you send your normal legal inputs, and it doesn't crash. This is typically a frustrating experience, so it's nice if you can have some kind of help from the fuzzer that says, okay, this is the history of what I did to your application. Maybe that can reproduce the bug. On the other hand, you might only be able to find cool, complex bugs by doing complex things and messing up your database in complex ways. So one of the ways we try to do this is, well, try to make chains of requests that hopefully do something legal and then mutate them so they do illegal stuff. In this case, I am using the example of building Spotify. You have a music database. You want to have some data on songs and artists. So first you create the artist, in this case Rihanna. Then when you have created the artist in your database, you can attach an album to it. And then when you have created the album, you can attach a song to it. And then if you want to delete everything, you should first delete the song, then delete the album, and then delete the artist, because otherwise you have songs that don't belong to any artists. So logically, what the fuzzer will do is it will try to switch around these operations and maybe delete the artist first at some point, and then see what happens to your database. Maybe your application is written well and will say, I can't delete the artist, or will say, I will also delete all of these albums and songs by the artist, but maybe it will just leave dangling references that later lead to problems. Then we spoke about coverage, and that's sometimes difficult because that means you have to instrument your application, which makes the fuzzer harder to use, and one of our goals was to make it easy to use. So we have coverage-guided fuzzing in two modes. Easy mode is where we do endpoint coverage, which is basically, did we reach all of your endpoints? That's easy enough. And did we get all of the status code out of them that you documented? So here it helps if you document your API carefully, since then we can see, oh, we tested a lot, but we didn't get any 404 errors from this endpoint. Let's ask for weirder things and hopefully get them. On the other hand, this also allows us to see if your application, for instance, gives a 500 status code and you didn't document that as being normal, probably you didn't, then we can report it as a bug. So it works both ways. But of course, it's nicer to have serious coverage of your application. So if you have the source code, I presume you do, you might be able to install coverage instrumentation, which we here call the coverage agent, in your application, and then the coverage client in the fuzzer, which speaks the same language, can connect to it and better understand how much of your application is been able to test. So yeah, that is better, but can be a bit difficult. We have multiple solutions depending on your back-end language, since that kind of differs. If you write Java, there is a very nice coverage library used for unit testing, or in our case, fuzzing, which is called Jacoco. So it speaks a certain protocol that we wrote a client for, that the fuzzer can understand the coverage. And then the client connects to the coverage agent in your application and tells the fuzzer how it's doing. Same for JavaScript and Python. There are coverage agents and clients that speak LCOV, which is a protocol about coverage, that you can use to test if your application is being covered. We tried to make the fuzzer extensible in this regard, so that if you have another language, let's say Go, and you are faster than us, you could write your own coverage agent and client and submit it, and then we would, of course, happily include it in the fuzzer. So yeah, this also depends a little bit on what people are using. Our clients were already quite happy with Python and Java, but maybe you are not. So finally, what happens if you find a bug, right? If it breaks, then there are a couple of things that could have gone wrong, and we try to inform you about those. For instance, maybe you just returned a status code that is not in your specification. This can be a documentation issue or a code issue, so we tell you about it, but we allow you to disable this kind of warning as well. Or you could return a structure that doesn't look like it should look. We had at some point a nice success where an application returned the entire database instead of just one entry. So then we say, this doesn't look like what it's supposed to do. And that was a nice bug to find. Authentication problems are harder to find, right? If you ask for Thomas's data and you get mine, then that looks good according to the specification. It's not good. So that's harder to detect. As is data loss. If you have some malformed input that deletes the entire table, yeah, that's kind of sad. And hopefully the rest of the campaign, like you want to access the resource that you just created with this weird name, you will see that the fuzzer detects problems and you will see the bug. Logic errors usually cause exceptions. Sometimes the application crashes, but usually not. So hopefully you can see this in your logs as well. One of our future features is also to connect to the logging of your application and record what is happening there at the time of the bug, since hopefully this helps you. So yeah, we currently detect these three kinds of things happening with your application, because usually it's a separate process, so we cannot really inspect it closer than you already do. And I guess I'm getting to the end now. We released this already last year, so you can actually just download it and try to use it. We try to make it easy to use. And we even have a movie that maybe we still have time to show, but maybe I will see how many questions there are, and if there are very few questions, I will click through to the movie, which is a demo on how to use it. So, are there any questions?
What's the most interesting bug you found using this?
I think I like the database dump the best. It was basically by malformed parameters, you could just ask it to give you a wildcard query on the database and get data that wasn't meant for you. Do you have a favorite?
Yeah, I would say the same indeed. Yeah, that was the most interesting. And also important to note, so we are not pen testers ourselves, so we work on the innovation and we don't do active testing. So I think it would be interesting to ask the community around the fuzzer what they actually find. That might be nice to have in the repo as well, in the README.
Like often you catch boring things, like this is an exception that wasn't caught or wasn't handled, or this input is not being properly guarded against injections, and we posted invalid Unicode, so it crashes, and then you look at the code and you notice, oh, maybe we should check this in any case. So, but yeah, those are not the spectacular things, I guess.
How useful does it work if you do not have a view of either the logs on the back end or the application crash state? So you can look at 500 errors, but is it still useful if you can't view the back end of the application?
It's a lot harder to use if you don't have concurrent logs. We do, while fuzzing, since HTTP is relatively slow compared to like fuzzing an application that you have in process, we do keep a database of all the inputs sent. So if you look at a crash and you're like, I don't know what happened here, you can basically see a record of all previous requests and replay them while looking at the logs, hopefully, and see what is going on. But in the end, logging is usually written by yourself and therefore easy for you to understand.
Yeah, so mostly useful if you have the source code and your own environment to replicate the application. But if you're doing black box, gray box testing from a pen testing perspective, this is less useful.
Yeah, also mainly because if you do it on a live environment, there are mitigation plays to send a lot of requests, so you will be banned within a minute, probably.
Yeah.
So.
I'm looking at it from the perspective from
Yeah.
It is useful if I can pull the Docker container containing the source and then inject it into it, so I have control over the logs,
Yeah.
the source code, but it's not really useful if
Yeah, or if it's running somewhere without all the mitigations for the number of requests that you can send. So that might also still be valuable. And the main thing you can also catch is deviations from the spec. So we do assume that you have the spec, and any deviations can still be of interest. So not only 500, but you might also have just weird returns of other.
But this,
Yep.
I see a lot of, during pen tests, I see a lot of specs that do only comply on paper with their output model.
Yep.
And the output model can differ because they didn't create the spec and then generate code from that spec, but they generated code and then hopefully the spec should be similar to what.
Yeah, hopefully indeed. Yeah, so the ideal world is that you have a spec and you build your code and then they are the same. And they should be the same. I think you should also strive for that. So it's also a tool that a developer can actually use to test whether they align with their spec and investigate any deviations. So it would also be, it would be helpful for developers and maybe a bit less for pen testers in that case. Yeah. If there are no other questions, so we also brought stickers, so I can put some on the bar, so you can promote the fuzzer or just put it on your laptop because you like stickers. That's also fine. And I'm not sure whether we still have time for the video, but it's also available on YouTube, or you can find it in our repo. So if you go to that URL, it's a demonstration of how to work with WuppieFuzz in the basic sense, easy mode, with a nice voiceover by Erieke. So. Hope you can follow along. And there are also tutorials on GitHub itself, so thank you.
Thank both of you for the nice demonstration and talk about WuppieFuzz.
Yeah.
Also, for both of you, a nice thank you. And if there are any other questions or you want to see a live demo, I suppose you both will be hanging around during the conference, so make sure to get in touch with them. Thank you.
Yeah, thanks.